What up, dudes? All right. Tutoring is not open. I'm sorry, it's late. I caught the bus, and I guess the rain caused the bus to be late. So it's open tutoring. I'm fair game. Any question? I don't have a plan as far as what I want to cover. The only rule is I probably am going to shy away from doing your homework directly for you, but I'll do a similar problem to kind of show you the concept. So, moving from standard form to factored form to vertex form. All right, that's kind of an advanced question. Can I cover that later? Sophia? All right. If nobody else has a question, I'll start covering that. Any other questions? Okay, Sophia, I don't even think we lectured on going from standard to vertex form. We haven't shown you that yet. Is that in your homework? Oh, okay. All right. I'll cover that. Does anyone else have any other questions? If not, I can answer Sophia's questions. You want me to warm up with that while you folks start thinking about what you want to ask me?
Yeah.
All right. You see that? No, very well. Let's see. Can you see that? Oh. Let me try something. Did that work? All right, how about now? Can you see that? All right. Sophia, I'm going to answer your question, and I'm warning everybody, and I told you guys ahead of time, this is kind of an advanced question. We haven't even covered this in class, but we will. In fact, I think this might even be the next lecture. So if you get confused as to what we're doing, don't freak out. Don't just be like, oh my gosh, I am so lost in math. Because this is the hard part, all right? To do what you're asking me to do, Sophia, you're asking me to do this technique called complete the square. So I'm gonna make up an equation. X squared plus 4x minus 7 equals 0, or no, equals y. Gosh, let me see if I even remember how to do this. Okay. So, here's the thing. You can't factor this thing down. We can't do that trick where we put two parentheses, and we have an x and an x, and then we think about, okay, there's a negative here, so it must be a plus and a minus, and then what are the factors of 7? 7 and 1, 1 and 7, that's it, really. You know what I mean? And I can't add 7 and 1, or, 7 minus 1, or 7 plus 1, or 1 minus 7, or any of those combinations to get the number 4 at all. So we're stuck. This is standard form, and I'm trying to put it in factored form, but I can't because we're stuck. So we use this really powerful technique that you should have learned back in Algebra 1, and I'm going to show you how to do again. But what you do is you take this middle number, that's the B term, right? There's an A, B, and C. You take the middle number, the B one, the one that has an X right next to it, and you divide it by 2, and you square it. So what's 4 divided by 2?
2.
2. And then square that. 4. Okay, so x squared plus 4x, and I'm going to add 4, because that's what that middle number divided by 2 squared is. Oh, I still have my minus 7 out here. Got it? But I can't just go around adding 4 to one side of an equation. Just like,
add it to the other side.
yes, I love that idea. You can add 4 to this side and add it to that side, and then it would be fair. Or how's about this? What if I added to this side and I subtracted from that side at the same time? Because essentially, that would be like, if I were to move this onto that side, it would be like adding 4 to that side. And I just did exactly what, I was thinking Sierra? No, it's Ciara. I was doing exactly what Ciara suggested, but instead I moved the 4 over here. Essentially, all I did was I added 0. Add 4, subtract 4 at the same time. I did nothing to the equation. I didn't really change it. Okay? But the nice thing about this is, see this part right here? That can be factored. That can be factored very nicely, in fact. So the double underline part, I have an x and an x. I'll have a plus and a plus, right? What are the factors of 2? Or, I'm sorry, I gave you the answer. What are the factors of 4?
4,
4 and 1. 4 times 1. What times each other gives you 4? And they're answering 2 and 2. Exactly. So let's try, we can either try 4 and 1 or 2 and 2. But if we tried 4 and 1, can you add 4 and 1 to get the number 4? No. But 2 and 2 works. Okay, so that's the answer. Okay? In fact, actually, this is a very special factorization. It's called a perfect square trinomial. The trinomial part is this part right here, because there's 1, 2, 3 parts. Mm-hmm. And it's a perfect square because really I can just write this as x plus 2 squared. Does that make sense? And then I have to deal with this part right here. Well, that's negative 4 minus 7, which is negative 11. Yeah. So I didn't change anything in the equation. I just made it, I just dressed it a little bit differently. If you want, I'll prove it to you, and I'll do it real quick. I won't keep turning around and asking you. But why don't I FOIL this out? I'm gonna like undo what I did, and I'll show you. I mean, you'll see what happens. If I were to FOIL this, this would be. Remember, this really is the same as this, and so I'm FOILing this. So that's x squared plus 2x, right? That's the outers. And the inners is 2x plus 4 minus 11. So that would be x squared plus 4x. And then 4 minus 11 is negative 7. Look, this is the same thing as that. So all I'm saying is the stuff in the purple is just for me to kind of verify that this thing right here is really a secret code for that thing right there. It's the same thing. Does that make sense?
Yeah.
But the nice part about this thing down here, the extremely nice part about this thing down here, is this is in that form that I kind of started to introduce yesterday, which I haven't even uploaded the video for yet. I got to make sure to do that. But I kind of started to introduce yesterday. This is a parabola that I dropped down 11. And I moved to the left, 2. So if I were to graph this parabola, I'd just say, all right, this is a regular parabola, drop down 11, move to the left 2. There it is. I mean, if you wanted a prettier graph, I could make little tick marks and everything and do it on graph paper. But that is changing the standard form, which is this, to vertex form, which is something I just started to introduce to you. And the trick really is this idea of taking this middle number and dividing it by 2 and then squaring it and adding that. to the thing. But you can't just add one thing to one side. You have to subtract it from that same side as well. Because essentially, we're just changing. It's like I wore the same. I'm the same person, but I'm wearing different clothes from yesterday.
Right.
Hopefully, I mean you would assume I'm wearing.
You always wear those pants.
Yes, that's true. I always wear these pants, but you didn't know what pants I wore yesterday. So, So, I'm the same person. I wear different clothes yesterday. This is the same equation. It's just dressed a little bit differently. So, plus 4 minus 4 doesn't become 0 in the equation. Yeah, it does. It does. It is 0 in this equation. But the thing is, it is 0 in this equation, but the thing is, by adding 0, I'm not changing anything, but that plus 4, this part right here, gives me this part right here that I can use this for perfect square trinomial factorization. And I think I'm going to cover this on Wednesday. I might not even cover it I might not even get to it on Wednesday. I know if it's not coming up on Wednesday, it's definitely coming up on Monday. So within the next 2 lectures, I'll get to this. Got it? All right. Does anyone have any questions? I'm assuming that you folks don't want homework on. I mean, like you didn't come to tutoring so that I can teach you the stuff that's like I haven't even taught you yet, but probably reteach you the stuff that I have taught you, right? So I mean, no offense. I mean, like I'm glad you asked that question, and let's keep going with that. And I'll answer your questions so long as nobody else has any other questions. Does anyone else have any other questions, like backlog stuff from like chapter 1? Oh, there we go.
I got step number 13.
Can you tell me what 13 is? Because I don't want to go through and look it up.
F1 equals 100, and then fx plus 1.
Oh, I see. This one's a good one. Fx plus 1
equals fx plus 10, and then for x over 1.
For x over
Greater
1?
than x. Or
Oh, for x greater than 1. Huh. Well, that looks hard. Is that exactly how it's written?
yeah.
All right, fine.
The 1 is inside the parentheses.
Yes.
Oh, okay. And then this is not inside of parentheses.
No.
Yeah.
It is. Oh wait, no, it
Yeah.
isn't. Yeah.
X
Oh.
is in parentheses.
Oh, wait, this is f of x.
Yeah.
Yeah.
Close parentheses plus 10.
Yes.
Okay, that it all makes a big difference as far as what this thing is saying. And I told you I wouldn't do your homework for you, but sure, let's do this one. All right. I'll tell you what. I remember this homework. This is the one where if I gave you 2 points, then you could solve for this equation. You could solve for these lines. If I gave you like, I don't know, 1, 100 and 2, 150 or something like that. If I gave you 2 separate points, never mind this. Let's not worry about this. But if I gave you 2 separate points, you could find the slope between these 2, right?
Right.
The slope would be 50 actually. It's y2 minus y1, so that would be 150 minus 100, which is 50, right? And then x2 minus x1, which is 2 minus 1, which is just 1. So your slope is 50. And then you would choose 1 point, probably that one, and figure out what the intercept is, and then you would be able to get that, right?
Mm-hmm.
All right. And that was like the previous problems. But this one looks crazy, right? Let's just try plugging in some numbers. Because we have 1 point. This is one of the points. This really means if x equals 1, y is equal to 100, right? So 1, 100. They gave us one of the points. We just need a second point. So, what if I let, and I'm going to write this down, I'm going to remember this is what I'm doing. Let x equal to, choose a number.
23.
You choose the hard numbers. All right, fine. 23. I would have chosen 1. That would have been a lot easier, but 23. Okay, so if I let x equal 23, I'm going to replace all my x's with the number 23. And as long as it's a number that's bigger than 1. 23 is bigger than 1. So I'm going to plug 23 into here. So this would be f of 23 plus 1. What is 23 plus 1?
24.
24. Equals, all right, wait. 1 second. I'm gonna override you. Well, let me finish this off and then. Equals f of what? What was x? What were we letting x equal to?
23.
23 plus 10. All right. Here's the problem that I'm saying, that I'm realizing that we came across, is we would be able to know what f of 24 is if we knew what f of 23 was. But the problem is we don't know what f of 23 is. Does that make sense?
Mm-hmm.
So can I just say, you know what? You chose a bad number. Why don't we choose this number? Let x equal to 1. And I'll show you what's going on. Okay? So let's plug it in back into here. F of 1 plus 1,
2.
okay, equals f of what?
20.
1.
Oh,
2.
1.
1. We're letting x equal 1. Plus 10. Now, darn, if I could know f of 2, if only I knew what f of 1 is equal to. Oh, I wonder where that could be. It's so hard. What is f of 1 equal to?
100.
100. That's amazing. I can't believe you figured that out. All right, 100 plus 10. Actually, I take that back. That was really mean of me. It's not that I can't believe you figured that out. It's that never mind. F of 2 is equal to 110, or 100 plus 10, which is 110. Make sense to you? Good?
Yeah.
So, look, I have a second point. It's 1 comma 110. Oh, no, 2 comma 110. Because if x equals 2, y is equal to 110.
Right.
2 points. I can do the rest of the problem. Cool?
Right.
I don't... All right, here. How's about let's do a challenge today? My challenge is this. If I ever say, if you ask me, hey, can you solve this? Can you help me out with this? I'm really stuck on this. Yeah, I'm really stuck on this. So what I would say is, if I ever say in this tutoring session or in chemistry tutoring session, oh, that's easy. Let me show you. I'll give you a point, a free point of extra credit, because I hate it when teachers do that to me, because I've been studying algebra for maybe 20-something years. So, of course it's easy for me. You've been studying algebra for 2 weeks, 2 months, maybe. And you've been learning this new stuff for like 2 hours, 2 days, maybe. So, of course it's not easy for you. If I make it seem like it's easy, well, okay. But don't let me tell you, oh, that's easy. Because it's not. It's not. It's tough for you. Can you do me a favor? Can you plug me in somewhere? There's got to be a plug down there. All right. Any questions? Online, anywhere else? Oh, it's way over here. Here. Oh, that's me again.
Oh.
There we go. Yeah. Do you have another one? That was the only question. Oh, you need me to open up stuff.
Yeah, the 1.9, but I can wait.
All right. After I answer your question, I'm going to sit down and open up all of these stuff. I'm going to open it up. Yeah, if you're online and you don't really need any help, then you can just kind of like hang and watch Mr. Dalday play his monkey. Yeah, I mean, like dance like a monkey and whatnot. I'm not going to dance like a monkey, but sometimes I do. I think my arms like move when I move my arms and whatnot. I'm like, don't you get it? All right. Anyway, Cameron, you had a question.
Yeah. So the Algebra 1 review 3.7 question 1.
All right, you're gonna have to tell me the question, or else I'm gonna have to look it up, and it
Okay.
takes out time.
Okay.
Sierra, we're good when I give you those 2
Yeah.
points, right? You can get there.
Yeah.
All right. Then I don't feel bad. That way, I didn't solve the whole problem for you.
No, it's okay.
All right. Cameron,
Okay. So
you want to show it to me?
yeah, here.
Whew. Okay. Oh, I think I remember. This one was wrong. I'll have to regrade it, but we'll talk about it.
Okay.
F of x is equal to 2 times x plus 4, x plus 2. I think that I put in the wrong answer, and the reason why it's saying this question has been regraded is I think it gave you a 4 out of 4 points.
Oh, okay.
Well, we'll talk about it. I think it's a good problem. All right. And it gave you a bunch of graphs. And I forgot what the graphs look like, but I'm not even going to look at those. There's 3 different forms of quadratics that I taught you. There's the standard form, there's the factored form, and there's the vertex form. The vertex form we've just started. The standard form is what we started with, and then the factored form is kind of in the middle. We finished with that, and that was almost pretty recent. What form is this one?
Factor.
Factored form, exactly. Very good. When I have things in factored form, what kind of information am I able to draw out immediately?
X-intercepts.
X-intercepts, good. What are the x-intercepts of these things?
-4, -2.
Perfect. And x equals -2. I'm also able to get this information right here. This number right here acts just like the a in all the other forms. That a is the same. The ax squared plus bx plus c. You also have a times the factored form, or you even in vertex form you have a times x minus h squared plus k. That a is the same a. It's the same. It does the same things. So, okay, Genesis, I'll answer your question in just a second. That a does the same thing. So in this case, what does the a doing? What is the a doing? Is it a happy face parabola?
Yeah, it's a happy face parabola and it's vertically stretched.
Okay, 1 second. Kim, I might have other students coming in. Just let them know I'm in here. Happy, vertically stretched by a factor of 2. Very good. So, all I'm doing is I'm going to look for the parabola that has a x-intercept at -2 and -4, right here, and it's happy. So whichever parabola has something that looks like that, that's what we choose. We cool? All right. 3.7, numbers 2 through 6 has confused you. All right. Genesis, give me a second. Here's what I'm going to do. It's cool. Don't worry about it. I'm not off about that kind of stuff. Give me a second. I'm going to go through and open up your quizzes. I will open things up till Friday. No, till Thursday. I think that's fair. And you want me to start, what is the earliest you want me to start back at? 1.9 you said? This is on review, 1.9. We're not going all the way back to functions, are we?
Are you talking to me?
No, I'm asking everybody. What's the earliest assignment you want me to start opening up?
1.9.
1.9. And do you guys need more attempts? Is that what's going on?
No.
Or did
just
it
haven't
close?
started it. It closed, and then I asked you to open it.
It's not that I never did. It's just I told you I
closed
would.
on the 10th.
Oh, okay. Yeah. Yeah, it closed on the 10th, and I bet you it's because I pushed it back a bunch of times because it was due back on August.
Yeah.
All right. But I'll open it up till Thursday, so you have to the 17th, and you don't need any more attempts.
No.
All right. Is there any other ones you want me to do or to not problems? I'm going to answer your question in Genesis in just a second, but is there any other assignments you want me to open up? All right. Genesis, why don't I go back and answer your question for now? 3.7 from 2 to 6. Hopefully I'm making a lot less mistakes, but I can't guarantee that either. Oh, okay. Let's see. Okay, all right. Let's do this one. Why don't I just answer one of them for you, and then you can do the rest of them. Oh. X1. Oh, okay. Oh. This is all one problem. 2 to 6 is the same problem. Fine, let's just do the whole dang thing for you. All right. Let me take a look at the graph one more time. Sophia, I'll answer your question in just a second, but let me take a look at this graph. All right, it's -2, +4, and -8. All right. Okay. Maybe the reason why you folks got confused with this problem is because I've asked it in a very complicated way. The answer is going to look like this: y is equal to a times x minus x1 times x minus x2, and the vertex is going to be h comma k, or x comma y, or something like that. And there's 5 different numbers that you need to put in here. So I ask you this question 5 different times. I ask you, what is a? Then the next part, I ask you the same question, but I say, okay, what is x1? What is x2? What is h? What is k? What's the x coordinate of the vertex? What's the y coordinate of the vertex? So I'm asking, in questions 2 to 6, I'm asking you for the same exact problem, but I'm just asking you for each of the pieces. Maybe that scared you or confused you. But it's really not that bad. First of all, let's kind of look at this graph and get an idea of what we're up against. All right? Why don't I put my guesses over here? The number A, What do you think that's going to be? Let's take a guess at it. Is it going to be positive or negative? Look at the graph.
Positive.
Are you sure? You should say I'm positive. All right. It's positive. What made you think it's positive? Huh? Yeah, it's a happy face. It's a happy face problem. Do you think it's a number bigger than 1 or smaller than 1? This is a tougher question. I think it's bigger. It feels stretched out to me. But I don't know. I don't know. At that point, I can't tell. But my guess is A is positive. I can definitely tell you that. Got it? All right. What about X? X1. What is X1? This represents what, again? Chris, Cameron, you had it, right?
The x-intercepts.
These are the x-intercepts. So where does this thing cross the x-axis?
2.
At -2. So one of the answers is -2. What's the other answer?
4.
4. Well, those were easy to get. I think that's the answer to question 3 and 4, right there. All right? We got to figure out what this is, but this is the answer for question 3 and 4. That's pretty easy. And we're going to take a stab at this one. This one we don't know for sure. If you pull up the problem, take a guess as to where the vertex is. Give me the x part of the vertex. You're raising your hand, or you're just saying 1. Oh, okay. Let's say 1. This is our guess. Remember, the green is our guess. We don't actually know yet. 1. What about the k? Sophia's saying -9. Why did you not say -7? What I'm teaching you is I'm showing you exactly. There we go. What I'm teaching you is I'm showing you kind of how my brain thinks, and I look at a problem and I say, this is I think what the answer should be, and then I'll go through the problem and do it, and then see if what I got came anywhere close to what I should have gotten, what I think I should have gotten. Sophia is saying that, hey, down here is -8, and it looks to me like the vertex appears below that area, so I'm going to guess maybe -9, -10 for the y coordinate of the vertex. I'll go with your guess. That's our guess. We don't know if it's right. Okay. Let me just check something real quick. Yeah, all right. So, let's do the problem. This part, question 3 and 4, those are easy. We know that. This is x-intercepts, and it's very easy to read those x-intercepts. So I know that this equation is y is equal to a times x plus 2 times x minus 4. Are we cool with that? These are the x-intercepts, and you're cool with that. At -2 and +4. Right? All right. This is an equation that says y, I can tell you whatever y you want, as long as you tell me that an x you want. But in this problem, we have 3 things we don't know. We don't know the y, x, y, a, or x. Right?
Mm-hmm.
But if we could find at least 1 point on this graph, then I can tell you if you give me an x, I can tell you the corresponding y. Can you find a point, a single point, anywhere on this graph? Okay, Genesis. Then my answer is Genesis said that she put this in. She put in -2 and +3 or +4 in for the answers, and they said they were wrong. That means I got it wrong. I need to fix it. Okay, but yeah, what's up?
I actually put exactly that, +2 and -4, and I got that.
Oh, I see.
I don't know.
Genesis, what happened was I switched it in my brain. I'm sorry. I think that you put +2 and -4, and that's the answer. But actually, actually the answer should be -2 and +4. So Genesis, I think you were doing it right and got the answer wrong. You were doing it wrong and got the answer wrong because I did it wrong when I put it into the computer. The reason being is because I already accounted for that negative sign when I told you the form of the equation is -x1, -x2. Does that make sense? All right. Yeah, I'll take a look at it and I'll fix it if I made a mistake. And as always, I'll give you. I always keep tabs on exactly how many mistakes I made, and I give you extra points in that teacher's comp grade assignment that you guys didn't even take, but you guys got like 50 points out of 50 on that thing. So that's just my gift back to you folks for making all these mistakes, and I apologize. Okay. Well, the reason why I couldn't have just asked for the x-intercepts is because I want you guys to understand this form and be able to take it all down. But anyway, let's go back to this. Sophia's saying, hey, I know one point on this thing. It's right here. It's 0, -8. If x equals 0, I can tell you what the corresponding y would be. So if I plug in 0 for x, I can tell you that y is going to equal to -8 in that one particular case. -8 equals a times x plus, or 0 plus 2, 2. 0 minus 4, -4. Does that make sense?
Yeah.
All right. So -8 is equal to a times -8. What is a equal to? 1. Divided both sides by -8. You get a is equal to 1. Positive 1, mind you, which is what we guessed it to be.
Right.
So that's how you find a. We're cool? And the reason why it works is because you can tell me, you know, you sure? You say, sure, that's the a for that one specific point, 0, -8, right? But what about for all the other points? And I'd say, well, that a is going to be the same exact a. You're just going to have different x and y values. Does that make sense? So if we can find the a for that one point that we found, then we can find the a for everything else, because it's the same way. All right. The vertex, that one's a little bit tougher to find. Can you mind if I erase this part? Yeah, Sophia, I already counted for the negative sides because technically the factored form has the negative signs already in there. Although when you usually see it, you look at this and you think in your head, oh, I'll just switch that in my head. This is the x-intercept is -2 and +4. You just have to be careful with those things. X-intercept is x, not x1. No. The x-intercept is x1. This is a specific number. Whenever you see subscripts on something, it has, this is a specific number, this is a specific number. This is a general x variable. This is a number and a number. We just got to figure out what those numbers are. That's why it has the subscripts. Can I move on to showing you how to get the vertex? All right. Where are the x-intercepts again? -2 and +4, right?
Yeah.
So, to find the vertex, the x-intercept is -2 and +4. To find the vertex, the x-coordinate of the vertex, what I want to do is I want to find the middle. So to find the middle, you take the average. When you take the average, you add two numbers together and you divide it by 2. If you had the average of 3 numbers, you would add all those 3 numbers divided by 3, and so on and so forth. In this case, we only have 2 numbers, so it's -2 plus 4 divided by 2, which is also known as 2 divided by 2, which is equal to 1. Hey, guess what? Our guess was the same as the thing. Yay! Okay. And then, if we know that the vertex is at the x-coordinate of vertex is at 1. I should put maybe x equals 1. Or in most cases, they say h equals 1. And that's only something new I'm introducing to you, this h and k. But that comes from when we got into vertex form later. It's just, instead of calling it x, because there's so many x's that we have to deal with, let's call it h. What happened to my screen? Huh, interesting. I might have to log out and log back in. 1 second. But if I'm still on it and he's regrading, will it still get it wrong? I don't know. But here's what I'll do, Genesis, is I'll actually go into the gradebook and change your points, give you an extra, how many? 5 points on your assignment. How's that? Just submit what you got and I'll give you extra 5 points. Because I understand. Or 2 points, because I only made 2 mistakes. So this is the x-coordinate of the vertex. We also know the equation, because we just solved it. It was y is equal to 1 times x plus 2 times x minus 4. This was from before I erased that. All right. How do I find the y-coordinate of the vertex? No, Sophia, if you got it correct, don't worry about it. It will take care of it. How do I find the y-coordinate of the vertex? I know how to find the x-coordinate of the vertex. You just take the average of the x-intercepts. How do I find the y-coordinate of the vertex? You guys know? Yeah.
You just put the x in for x.
Yeah. This tells you any y value for whatever x value you're interested in. If you're interested in the x value x equals 0, then you plug in x equals 0 and it will tell you what y is equal to. If you're interested in x equals 100 or 23, you plug in 23 in here and it will tell you the y value for x equals 23. We're particularly interested in x equals 1 because we want to find the corresponding y value that corresponds to that x equals 1 thing. So all you got to do is plug in 1 over here for any x's you have. So you have y is equal to 1, I'm not even going to write that part, 3 times negative 3. Okay? 3 times negative 3 is negative 9.
Oh.
Dang, that's close to our guess. In fact, that's not only close to our guess, it's exactly our guess. I'm not saying that what you should do is you should take a look at a problem, guess all the answers, and say, I'm done. But what I'm saying is, if I calculate it out over here and I end up getting negative 23, then I'd be like, whoa, whoa, whoa. That's got to be, I must have done something wrong. Because that cannot be negative 23. You know what I mean? That has to be negative 9. If I ended up getting like negative 10.2, then I wouldn't be so worried, you know? But if I got like negative 400, I feel like, whoa, I must have messed up something over here. Right. And I would go back and check it. So this is why Genesis is saying that she accidentally put in positive 9. Yeah, it's negative 9. I mean, right there. That's exactly. You accidentally put in positive 9, but you look at this and obviously it's got to be negative 9. Yeah. So when you look at that and it's like, oh, there's my mistake. What I'm trying to teach you to do is look at something and say, is that even reasonable to get as an answer? Positive 9 is unreasonable to get as an answer. Your parabola doesn't go like this. It doesn't come down and then spike up to 9 and then come back down. That doesn't make any sense. So you go and make sure you check it. And I'm showing you this because when you do problems, it won't take you as long as I'm doing them on the board because I'm explaining every step and I'm showing you what I do immediately. I take a look at it and say, here's my guesses for all the answers. All right, let's do this problem. That kind of stuff. If you get good at this technique, then when you take like tests like multiple choice tests, you can immediately cross out answers. You just look at it and you're like, this is unreasonable, this is unreasonable, this is unreasonable, you know. And if you get to the point where you don't have any time, you can just say, unreasonable, unreasonable, here's my guess. I'm going to take a really hard test on Saturday. It's called the GREs. It's like and it's a physics GRE. And my technique that I'm going to go in there is, if I can cross out 1 or 2 of the things as being unreasonable, I'm going to guess. I'm literally going to go in and do that. That's my technique. I'm going to solve every problem, but if I can't solve it,
Use the guess.
nope. Let's guess. As long as I can eliminate one or two. And maybe that would be a good thing to talk about real quick. The GREs is this test. It's like the SATs for graduate students. It's a really hard SAT. Have you heard of the SATs?
Yeah.
Yeah. Okay. In fact, it's exactly made by the same people who make SATs. It's just, this is the SATs on steroids. The SATs has this interesting grading policy. If you get the answer correct, they'll give you 1 point. If you get the answer wrong, they'll take off 1/4 of a point. They'll actually minus points for getting questions wrong. There's 5 options too, which is an A, B, C, D, or E. If you leave it blank, they don't take off a point, they don't add a point. Got it? So when you take the SATs, which you're going to next year, and I want to make sure that you do well in the SATs because it looks good on my part.
Yeah, but I'm graduating this year.
Well, then you better take the SATs soon.
I think I took,
You probably took the ACT.
yeah.
ACT actually ACT is a different. So SAT is, let me explain this one little bit to you. Don't go, there's like a technique that they taught you back when you were in elementary school where like if you have 10 seconds left, just mark everything C, right? Did you ever learn that when you were a kid? Cameron was like, yeah, I do it all the time. I start off and I just mark everything C. Done. Yeah, don't do that. Especially don't do that on the SATs. Statistically speaking, you have a 1 in 5 chance of getting it wrong, you have a 4 in 5 chance of getting it wrong, and it takes off 1/4 of a point. So that's not going to help you at all.
So it's better to just leave it blank?
It's better to leave it blank if you don't know it, but that's on the SATs. If on the SATs, and also the GREs, which is something I'm going to be taking soon, so I want to explain this to you. On the SATs, if you can at least eliminate one option though, then it's the best thing for you to guess. Does that make sense?
Yeah.
If the answer is A, B, C, D, or E, and you look at that and you're like, it can't be D, so you cross it off, then you should guess. Then statistically speaking, it's in your best interest to guess, because if you get it right, you get a full point. But if you get it wrong, which there's a 3 in 4 chance of you getting it wrong if you're just purely guessing, you only get 1/4 of a point off. Does that make sense? The ACT, which is the one you took, and the one a lot of you folks are taking, has become much more popular nowadays, is graded differently. They grade, I'll give you a point for everything you get right. Anything you get wrong or don't answer, I won't do anything. So if you've got like 20 questions left and they call like 5 more seconds, then just mark everything like whatever. Because if you get them right, you're going to get the points. If you get them wrong, they're not going to do anything.
Oh.
Does that make sense?
Yeah.
So the ACT is a little different, which I wouldn't recommend guessing anyway. I mean, I think they give you enough time to actually go through the whole thing. But I'm just saying, if you get stuck onto a point where you're like, oh, I don't know what to do, just guess on the ACT. And the thing that trips me out, this is the thing that bugs me, is my students take the ACT and I look at their scores, and they left like 10 of them blank. And I'm like, this is the ACT. Why are you leaving anything blank? Don't leave anything blank. You're just guaranteeing that you won't get those points. Does that make sense? On the SAT, if they leave things blank, then I'd be like, oh, okay, well, you must not know anything about it. I understand. Cool? All right. I'm going to log out and log back in because there's something funky going on with my computer.